So yeah, hi there all. Nice to see people from many parts of the world joining. So my name is Jeroen. I work with the Water Resources Management Group at Wageningen, and I'm happy to share some of the results of our research on social water productivity. And actually what you will see in the slides is that I use different terms. Sometimes I talk about social water productivity, sometimes I talk about pro-poor water productivity, and sometimes about socio-economic. I'll come back to that. If you have any questions, like Lauren said, just put them in the chat, and then I might be able to answer some already during the presentation or otherwise afterwards. So when we talk about water productivity, actually it's good to go and look at the SDG 6.4. So the Sustainability Development Goals have been set up some decades ago, actually, to think what should we strive for worldwide in 2030, so in 10 years from now. And the 6.4 is about water productivity. And actually it quite nicely shows two of the goals we have with that. Because the first indicator is about efficiency. The idea of indicator 641 is that we produce food with less water, or the other way around, with the same amount of water we produce more food. And why would we do that? Because that is related to the indicator 642, which says that we should have sufficient fresh water available for the ecosystem, for wetlands, for rivers. And the assumption is, and I think it's very good to understand that if we are more efficient or we have a higher water productivity, we will save water, we will conserve water, so we have more water for the environment. And perhaps that's not always true, but we will come back to that. What I want to do now is zoom out, because water productivity is not only related to SDG 6.4. Actually, it's related to much other national water policies and SDGs, like the SDG 1 on poverty, the 2, the second one on zero hunger, and 13, climate action, because water productivity has also to do with things that happen in climate change. It also is about economic growth, and it's very good to remind us that roughly half of the world's population lives on a daily wage less than $2 per day. So that's an enormous amount of people, and the water productivity, and especially social water productivity, is related to that, as we will see. But if we zoom out a little bit more, we see also the social responsibility of the companies and the consumers also related to water productivity. And also inequalities in the world are related to that. And that is actually the core business, let's say, of social water productivity. Because we have to remind us that on average the income inequality increased by 11% in developing countries from 1990 to 2010. And more than 75% of the population are living today in societies where income is more unequal distributed than it was in the 1990s. And the target for SDG 10 is that in 10 years' time, progressively we will achieve an income growth of the bottom 40% of the population at a rate higher than the national average. So actually making the inequalities less. So this is how you can see that water productivity and social water productivity is related to these other SDGs. Going back then to the core of water productivity, starting with the idea that crop water productivity is the yield divided by the water use. But this yield can be expressed in either kilograms per hectare per year, or US dollars per hectare per year, or kilojoule per hectare per year. And that is important, because that has to do with the goal you have when striving for higher water productivity. If we look at economic water productivity, we can say, okay, if we concentrate on the US dollars per hectare, we want to see how much economic return is made of a certain amount of water, let's say 1 cubic meter or 1,000 cubic meters. But the question asked with social water productivity is, who benefits from this economic returns? Is this a big investment company, or is this the workers that work in the field? And there you see the relation with these SDGs that are about reduction of poverty and reduction of inequality. Okay, to symbolize how money is divided over different stakeholders, you can look at this pineapple. And we see that a pineapple, for example, might cost 2 euros in the supermarket in Europe. And then Somo did a research and found out that only 4% of the money you pay as a consumer goes to the workers. So you might say, okay, buying the pineapple will help consumers or will help workers, but it's only a minor percentage. Okay, now we will look at the video, which explains this from the point of view of the case study of Peru.
In agriculture, water productivity is the amount of value in terms of socio-economic benefits, services and jobs created per unit volume of water consumed. The different stakeholders involved in agriculture receive different proportions of this value. For example, let's look at this pineapple. It was grown at a plantation in Costa Rica and is being sold at a supermarket somewhere in Europe. Research shows that of the revenue from the sale of this pineapple at the supermarket, 21% will go to the plantation. Within that 21%, 17% will go to the plantation owner and 4% to the worker. Social water productivity is an idea that describes how equitable is the distribution of value generated from agricultural output per unit volume of water used. Social water productivity can be used as a parameter for decision making when it comes to allocating the water available in a river basin or an irrigation scheme. For example, in southwestern Peru, a project was proposed to divert annually nearly 300 million cubic meters of water from the mountains, where it was being used by small subsistence farmers, to commercial grapes, asparagus and avocado plantations near the coast. The government initially approved the project on grounds that grapes, asparagus and avocados were high-value export crops and would yield much greater returns per unit volume of water. So this would be a more productive use of water. And this was kind of correct. The net income per 1,000 cubic meters of water used for asparagus was around $935, about 5 times the return from subsistence farming of staple crops such as beans by small farmers in the highlands. But on closer examination, it was revealed that plantation owners would have pocketed most of those $935. Plantation workers or small farmers in the area would have earned only $75 per 1,000 cubic meters of water, which is only half the benefits being drawn by farmers in the highlands. This shows that the social water productivity would have been higher if the water was used for smallholder cultivation in the highlands than if it was diverted to plantations on the coast. The discussion around boosting water productivity is invariably a discussion around competing uses and trade-offs. This is especially true in arid or semi-arid countries where water is a scarce resource. For example, for a few years now, commercial farms are being developed and are expanding rapidly in the middle of Egypt's desert areas, irrigated by fossil groundwater from the Nubian sandstone aquifer system. These commercial farms are highly water intensive. They take a heavy toll on the non-renewable fossil groundwater reserves. Much like the commercial plantations in coastal Peru, the social water productivity of these desert farms is limited. They focus on export crops like Egyptian olives. However, the Center for Environment and Development for the Arab region and Europe, an intergovernmental organization, recommends that a more socially productive use of this fossil groundwater would be for domestic purposes, such as subsistence farming, and use as a strategic reserve for a growing population.
So this video actually explains quite well the overall idea of the pro-poor water productivity. And the idea is that in the equitation we would say that what we calculate is the income for the poor people and divided by the water use. This sounds sort of simple, but what we will see when we go into the details of the calculations, we will see it's quite a challenge to make these calculations. So let's go back to the example of the video, but let's dive a little bit deeper. So we have this water flowing in the high Andean mountains. Actually, it's diverted because otherwise it would flow to the Amazon basin. It's diverted to go to the Pacific and then be used in the coastal area. The water footprint of a kilogram of grapes, table grapes, is about 680 liters of water. So this project was proposed by the Peruvian government to divert this water, and as explained in the video, that would mean that the water is taken from the high mountains and brought to the coastal area. And like explained in the video, we have 20 times more of net profit for the owners of the land comparing asparagus with the subsistence highland agriculture. But actually in the coastal areas, the land is not a scarce resource, it's the water. So we should look at how much net profit is being made from the point of view of water. And then we see still a difference of 5 times more profit per cubic meter of water for asparagus as compared to the subsistence highland agriculture. However, as explained in the video, going back to the pineapple, it's only $75 that goes to the plantation workers, and of course the $180 per 1,000 cubic meters stays with the subsistence farmers. But now let's go to the details of the calculations that are behind these numbers. These are a lot of numbers, and I'll explain some of the important things here. Well, first of all, let's make a connection with the WaterPIP program. As the WaterPIP program tries to make much better estimates of production and of water use. Because what we did in these calculations, that you see here, the water consumption in this line, that is just calculated with aqua crop of FAO. This is a rough estimation, but it's not based on the actual weather conditions in that area at that time, and it's a rough calculation. Also, the average production here, that's an estimate from literature. That is not a real calculated or real observed production. And actually for all the numbers you see here, it's very good to realize that there are certain margins of uncertainty. For example, the prices, cost of inputs, and the prices you get for your produce, that depends on market prices. So they can go up and they can go down, and they can be different from different places. Also the labor requirement, that is very important, because employment, that is actually where you see that the pro-poor water productivity makes impact. If you have more employment, then the money is distributed over more, let's say, relatively poor people. But it's not only the plantation workers, it's also people higher up or down the production chain. So we have people that work in factories making fertilizer. We have also people working in package plants. But it's very difficult to attribute hours or days of work to one product. So in a packing station, for example, you might have different products that are being packed there. And the asparagus are only one. So in the literature you can find rough estimations, let's say that for each full-time laborer in the field, you might have 30% more labor generated in the transport and packaging. But that's a rough estimation. So actually it's very good to take into account that these numbers are estimations. But we see another important thing in this table. Until now, and in the video, we have talked about asparagus, which are in this column. Remember the $75 for 1,000 cubic meters of water being consumed. But if you compare now to table grapes, also grown in the Ica Valley, $200 for the workers. Actually, that means that table grapes generate more income for poor people as compared to the potatoes in the highland. Very different from the asparagus. Why? Basically, because of the number of jobs being created much higher in table grapes. And that is because we have this labor of picking the grapes and all sort of manual labor being needed for pruning and selection of the grapes. Also, when we compare, for example, the potatoes with the maize in the highland, we see that yes, the potatoes, they generate a fair amount of income for the poor people, whereas we compare it to the maize, it's much less. So actually, when we compared the numbers in the video, we compared, let's say, the potatoes with the asparagus. If you would have compared the corn with the table grapes, the conclusion would have been very different. So it's very important to be specific about the sort of crops and cultivation systems we are talking about. Okay, let's now go to a second example in the Cauca Valley in Colombia. So this is a production system that is dominated by sugarcane. And in the previous webinar, we have looked into sugarcane and a lot of details about water productivity of sugarcane. And now we can look at a specific case where the socio-economic water productivity leads to quite some tension. So let's see. So we have sugarcane, and that is the crop that you will see most in the Cauca Valley. But we also have organic rice that's being grown by smallholder farmers. And we have cocoa. These are small plots by poor farmers in mixed fields mixed with other fruits. And actually in the Cauca Valley there's a struggle for water. It's a struggle about the legitimacy of sugarcane. What you see is that in the last decades sugarcane has expanded, because sugarcane did not always dominate the Cauca Valley, but because of several projects reclaiming land, which were wetlands before, now sugarcane has expanded. You can also see that the land and the water and the sugar industry is concentrated in the hands of few families. Those are well-known families, and yeah, they have become very rich by controlling the land, the water, and the sugarcane industry. What you can also see from the political point of view is that there is something like the elite capture of the state. That the regional government has several regulations that favor sugarcane production. For example, in the ethanol regulations and also in the exemption of paying taxes. What is the problem related to water? The main problem is the extraction of groundwater to irrigate sugarcane. And this affects wetlands. So this area used to be actually a very big wetland, and still there are parts of very important wetlands with high biodiversity. But as the groundwater table is lowering because of the over-extraction for irrigation of sugarcane, you will see that the wetlands dry up and the biodiversity goes down. There's also a social struggle over land and water. Actually, the indigenous population that lives in the hills surrounding the Cauca Valley, they have been in a struggle for decades over control of the land and over the water. And because of climate change, we see that there is an increasing need to irrigate also the lands in the hills, but also the sugarcane needs more water. And you see that the struggle over land and water intensifies. So now let's look at the pro-poor water productivity, or the socio-economic productivity. In the same manner as we did with the Ica case. So you see that there's this productivity of land per hectare, the added value, or say the net returns. And for sugarcane, they are double as compared with rice and cocoa of the smallholder farmers. So this is important politically because these numbers are used by the regional government to say, okay, we have to stimulate sugarcane because it produces 2 times more economic growth or economic benefit. And actually it's true. So you can say, okay, from the perspective of stimulating economic growth or economic production, it makes sense to stimulate sugarcane. If we look now at water productivity, so let's say the same added value, but now per cubic meter of water being evaporated, we see that for sugarcane we have almost $1 when the sugar is used for sugar for consumption, and almost 50 cents of US dollar when the sugar cane is used to produce ethanol. And for rice, that is a little bit more than 50 cents, and for cocoa, it's a little bit less. But here I have to say that we actually came across a big challenge, because cocoa is not irrigated. So how are we going to calculate or estimate the productivity of water in cocoa? Do we calculate the precipitation be taken up and used, evaporated by the crops, or do we calculate the marginal returns, so the extra returns, if we would irrigate the cacao plantations in a dry year? And another thing is that the cacao is grown in mixed fields with other fruits, so it's very difficult to calculate water productivity per hectare. We can calculate it per tree and then make an estimation how the productivity would be if we would have a monoculture plantation, but we don't have it. So we have to make quite some assumptions to make this calculation. It's important to take that into account, and when you present the numbers, it should also be explained how you calculate them, because there's a lot of choices you have to make. Now, when we go to the pro-poor water productivity or socioeconomic water productivity, you can see that in the sugarcane, only 6 cents of a dollar per cubic meter go to the workers. And that's even less when the sugarcane is harvested mechanically, which is now increasingly being done. Also, that point is very important in the discussion, because you might say, okay, from a social point of view, if you are a politician and you say, I want to reduce poverty in this Cauca Valley, I should stimulate manual harvesting of sugarcane. But actually, it's a very terrible job to do. It's much better to do it mechanically. So there is these trade-offs which are difficult and should be discussed. Then for rice, the same thing. So it's 25 cents of a dollar per cubic meter of water, which goes to the poor people working in the rice fields, or 20 when the rice is harvested mechanically. And in cocoa, actually, it's the highest. So from a social point of view, being a politician that wants to reduce poverty in the Cauca Valley, you should stimulate cocoa production, as that gives the highest return on cubic meter of water being evapotranspirated. So now we have seen 2 examples where actually the subsistence agriculture is more productive in terms of reducing poverty. However, we have also come across some issues that actually make the whole discussion on pro-poor water productivity or socioeconomic productivity quite complex. And I think that's very good to highlight that, because otherwise we think, okay, well, the conclusion is very clear. We should stimulate smallholder production or peasant production because it has a higher pro-poor water productivity. Whereas actually the situations can be locally very complex. Now, some points for discussion and to take into account are, you have to take into account the ecological effects. For example, also including in that the energy being used for pumping of water. So different farming systems have different energy use and also have different effects example, on pollution of water, something we call the gray water footprint also, and that is not taken into account in these indicators. And we'll see later on that if you make a framework, you will use, if you make a framework on different aspects of water productivity, as Maria will explain later on, you have to use different types of indicators. So this goes to this complexity of water management and economic processes, in the sense that if you try to capture these indicators in one number, then you don't take into account the differences you encounter over time, because prices change and evapotranspiration changes and labor input changes. And perhaps with some more precise data from WUR, we can reduce the uncertainties, but still there will be always uncertainties and fluctuations over time. The third point to take into account, and that's very important when we relate the indicators of SDG 6.4, the first indicator looking at efficiency and the second indicator looking at the water that is used for ecosystem services, then we see that actually the return flows might diminish when you increase the productivity. So actually there we have a relation that is not always favorable, in the sense that if I increase the efficiency, I will have more water for nature. That's not always true, because if I have more land, or I can intensify the crops with higher irrigation application efficiency, so perhaps also higher water productivity, I capture more water and I produce more, but I also might diminish my return flow. What became also clear, for example, from the Colombian case, is the cultural values that are not expressed in the numbers, in the sense that the indigenous population is in a struggle for water, because they attach different values on water on their lands compared to the sugarcane companies and the sugarcane farmers. This social value should also be taken into account, but cannot be expressed in the numbers. So if you go to the economic numbers, it's also good to look outside agriculture. So agriculture is an important user of water, but sometimes the alternatives for using water, so the pro-poor water productivity, can be higher for water use outside agriculture. And also there it's important to see who actually benefits most. Is it poor people, or is it rich investors? And finally, if we talk about pro-poor water productivity or socioeconomic water productivity, it's about the distribution of costs and benefits. So remember again the pineapple. If only 4% of the retailer price goes, or the consumer price goes to the workers, then we have to think if that percentage perhaps can be larger, and also what is the actually quality of the jobs that are being created. So many questions adding to the complexity of water productivity here. And with that, I want to end for now. We will come back to these discussion points and head over to Maria to explain the water productivity assessment framework.
Thanks Jeroen. Thank you also for the nice presentations.